briefly what is on test 1. Test 1 consists of chapter 2 and chapter 3, the probability stuff. So up to what we have done so far. So let me see. Yeah, let me get some pen colors going here. Okay, so chapter 2. First thing we're going to talk about in chapter 2 that we talked about in chapter 2 is central tendency, and I call that the 4 M's: mean, median, mode, and mid-range. So go through your notes, know what they are, know how to calculate a weighted mean. You had a weighted mean problem on your quiz. You had a weighted mean problem on your chapter 2 review. And there were a couple problems also in the notes videos also. So make sure you know how to do those. Median is your halfway point. Mode is the one that you find most often. And mid-range is that funky one that's high plus low divided by 2. We don't use it that much. Going back to these, you can get the mean and the median by doing 1-var stats on your calculator. So you go to put your data in your list and just hit 1-var stats, and you can get your mean and median there. When talking about the mean and the median, if the data is skewed, you want to use the median. If you have outliers, you want to use the median. It is the one that is least affected by outliers. Okay, so the things that go hand in hand, the things that go hand in hand are the mean and standard deviation, and the median goes with the box plot and the 5-number summary. So that's the next thing we're going to talk about. These 4 M's, my 4 M's I call them, talk about the center of the data. The next thing is to talk about the variability or the spread of the data. And you can use any of these things to talk about the variability or the spread. Range, high minus low. Standard deviation and variance, mostly we just talk about it in standard deviation, and IQR. IQR is Q3 minus Q1. Once again, to find any of these, you go to 1-var stats, and it'll give you the high and low, and you can just subtract. It will give you 2 standard deviations. It'll give you this standard deviation if the data set is a population, and it'll give you this standard deviation in S if the data is a sample. And you must decide whether your data is a sample or a population. To get the variance, all you have to do is take these and square them. So there's your variance. And like I said, 1-var stats gives you high, low, these two. And if you scroll down on 1-var stat, it also gives you Q3 and Q1. The larger the interquartile range, the larger the range, the larger the standard deviation or variance, the larger the spread of the data. Standard deviation is one of the more important ones, and standard deviation tells you if you have a set of data, let's see, these are all your data points. And let's say you calculate and your mean is right here. Let's say this is the mean of your data. Your standard deviation is the distance all those points are from the mean. Okay, if you add up all these green lines, these distances, and average them out, that's your standard deviation. So if you had data on the same scale, that's this data, and here's your mean, same mean. But if you had data that looked like this has a smaller standard deviation than this because it has a smaller spread. So the distance between that green line, that line of the mean, is smaller than these distances. So this would have a smaller standard deviation. Okay, one of the things that you have to know is the outlier formula. So the outlier formula is Q3 plus 1.5 times the IQR. Any number above that is an outlier, and Q1 plus 1.5 times the IQR, minus times IQR is equal to, whatever that is equal to, anything lower than that is an outlier. There we go. All right, box plots. Box plots are made up of the 5-number summary, and the 5-number summary is your min, Q1, median, Q3, and then your max. So your min and max, your high and low. And all of those you can get from one bar stats if you have a hard time making the box plots on your calculator. There are directions in the series of notes in chapter 2 on how to make and compare multiple box plots. So box plots, they must be on the same scale. So when comparing box plots, you want to make sure that they are on the same scale. So use one number line right up above atop each other. So let's say this is A and this is B. I can tell by using this. Oh. Hold on one second. I can tell by using this right here that 1, 2, 3, 75% of B is higher than, look at it, 1, 2, 50% of A. So that's one thing that I can tell. Another thing I can tell, I'm just trying to change the color here to blue. Another thing that I can see is that 50% of B, 1, 2, is higher than, their scores are higher than 1, 2, 3 of A. So those are things that I want and I'm looking for in sentences. Okay. Another thing that you need to make sure, and we had that on the quiz, and we had a box plot assignment that we did, and I made a video about. So if you have problems with that still, go back and look at that video assignment that I did. One was on bus times, and then I did the video on that. We did a synchronous session, and then there was a vitamin activity that you had to turn in and do. So go back and take a look at that if you still need that. Okay, shapes of graphs and central tendency. And there was also one on your quiz, by the way. Going back, sorry. So shapes of graphs and central tendency. You need to know if a graph is symmetric. It can look like this. Or a symmetric graph could actually look like this. That's a continuous. We'll talk about that. This one's a discrete. That's a symmetric graph. Or a symmetric graph could even look like something like this, just so that it is a mirror image in the middle of it. So it can even look like this, right? Okay, so all of these have all three measures of central tendency, right, smack dab in that line of symmetry in that middle line. So the mean, median, mode is all there. Okay, when you skew the data, for example, like incomes in the United States, the majority of us are here, and then we have a couple people that are millionaires, billionaires out here. If here's the median, that's 50% of America makes this much and 50% of America makes this much. The actual median household income in the United States is around $58,000. So half of this country makes $58,000 or less, and half makes more. The average income in the United States is actually higher. That's the mean, and it's pooled, remember, by your outliers. So the mean is always pulled by the outliers. This is a positive skew or a right skew graph. And then the same thing goes with if you flip it and you make a negative skew. A negative skew would be like your test grades. Most people got A's and B's on your last quiz, and then a couple people didn't do so well, or we had a couple zeros of people that didn't turn them in. And your mean was pulled down by that. So the majority of the people did well, and then the mean is pulled always by this tail, always by the tail. And this we call a negative skew or a left skew, either one. Okay, z-scores. Z-scores help you compare two different things. So the z-score formula is, oopsie daisy, I don't know what happened there. Uh-oh. Hold on a minute. I do not know what just happened to my Cami. That is weird. Hold on. Sorry. Here we go. Okay. Z-scores. Sorry, I don't know what happened there. Z equals your value minus the mean. That's a symbol for mean, by the way. over the standard deviation, whatever the standard deviation that they give you is. Okay, the higher the z-score, the higher the relative position. So if I have a z-score of 1.5 and I have another z-score that's 2.2, that has a higher relative position. And we'll get into that a little bit. All you need to know is that for right now. That has a higher relative position or relative standings. Those are z-scores. All right, chapter 3 is the probability chapter. So this is everything that took you up to your first quiz, all of this. And then the chapter 3 is your probability chapter. Make sure you know what just the simple probability is, what sample space is. Complement is just 1 minus the probability of what you want, of the event that you want. It's the opposite. Make sure you look at your dice chart and you have that ready for the test, because there's some dice questions on it. Make sure you know what a standard deck of cards is. Understand that you have hearts and the suits. There are 4 suits. There's 13 of each. If you don't know that, watch a video and learn the standard deck of cards. And then remember, you have mutually exclusive or not. There was a video on that and homework on that. So mutually exclusive is an or. That means or and mutually exclusive is both ors that you're adding. So if it's mutually exclusive, it's just A plus B. That means they have no outcomes in common. So you just add your A, you add your B, and then that's your answer. Pretty simple. So you are going to probability of rolling 2 dice and getting a 4 on 1 or, and then or a 5. So that would be 1 6 plus 1 6. It's pretty simple. All right, if they have something in common, then you must subtract out the both. All right, and we're going to do a whole bunch of review on our synchronous session on this. So if I said a 4 or even, you have 1 out of 6 for the 4. Even would be 3 out of 6, but you counted that 4 twice. So you've got to subtract that 1 out. That's an example of not mutually exclusive. Basically, anytime you're doing an or problem, always think, hey, do I have to subtract something out? Do they have anything in common? Mutually exclusive means that that would be 0. They have no outcomes in common, right? Another way to do or probabilities is with the Venn diagram. And there were several in the notes on that. This part right here means that it's not mutually exclusive. They have an outcome in common. That is your probability of A and B. If they're mutually exclusive, then their Venn diagram looks like this. There's a circle for A, circle for B, and there's nothing in common. This is not mutually exclusive. When doing a not mutually exclusive one, you should always do this part first and then subtract it out and then do anything outside of there. We will also review those on the Google Meet session. When I do the review, I'm just kind of going over all the concepts. Independent and dependent is and probabilities. Okay, that is the probability of A and B. This usually means and then, so you do one and then you do the other. These are always multiplies. So you're going to do the probability of A times the probability of B if they're independent. If they're dependent, that means B happened after A, so you've got to take that into consideration. You still multiply, you just have to think about it. So if you're doing 2 cards and you pull 2 7s out of a deck of cards, it's 4 out of 52 for the first card. If you put it back in and shuffle, it's independent. It's 4 out of 52. If you don't put it back in, then it's going to be 51 cards left and only 3 7s left. That makes it dependent. So that's the difference between your independent and dependent. This second fraction is called a conditional probability. This line right here means given I've already pulled a card out of the deck, what's this one? So that's what the given is. Given, you have to consider when you're doing them, especially in tables, that given means literal. That's all you're given. You're not given anything else. So everything else in the problem gets covered up. Once again, I'll address that in the video when we do the problems. Then another type of independent and dependent you can do is tree diagrams. This is A, and then this is B. So this would be your first pull of the cards and then the second pull of the cards. Or you're going to do one thing first and then another thing. So you pull something out of a bag and you replace or not replace, it doesn't matter. And then this is your second pull. So we'll talk about tree diagrams. When doing tree diagrams, you always multiply along these branches and you always add in between when you're calculating them. And then the last thing is at least one probabilities. The thing that everybody has a problem with. Remember, I call these ALOs, so I don't have to write them. So probability of ALO is always 1 minus the probability of the complement, the opposite of it. Okay, so let's say I am doing a problem and I have, I don't know, I'm taking a driver's test and I have an 80% chance of passing on the first one. And let's say I pick, I think this is one of my examples I made, 5 students who are going to take their driver's test. Okay, and my question is, what's the probability of at least one of them failing? Okay, so at least one fails. As soon as I see that ALO, I do 1 minus the opposite of what's in here. The opposite of what's in here is pass. And then I'm going to do it to the 5th power because I'm assuming they're all independent. So I'm going to do 1 minus 0.8 because that's the probability of passing to the 5th power. And that's all that's on the test. So make sure you go through, make sure you have all of your notes for all of these things organized and ready to go. This is going to be a timed test. You do not have an unlimited amount of time. However, you can use anything that I have given you to do the test. So maybe print out the quiz, maybe look at the worksheets, the homeworks, but this is basically everything on the test.